Okay, here it is. I don't know what else I can give to you. You have to do some studying on your own. Please remember, the review questions aren't enough either. You have to look back and look at some of the stuff we did, whether it be in the notes or from the homework. Okay, this right here, what I have up here is not alone, not going to cut it. All right, either is just maybe doing a couple review questions. I'm going to do some review questions with you. If you go to page 23 of your packet, up on top, I've given you most of the basic figures. I have not given you every area formula you need there. Okay, please realize that. That is not everything you need up top. Those are the basic figures. All right, there's some stuff up here I do not have on those area formulas at the top. Just warning everybody for that. Okay. And one last reminder, there will be questions from the January 2016 exam we did last week. All right, whether it be multiple choice or short answers, I put a couple on there. Finally, if you choose to do so, I believe at the end we put textbook questions to try. Okay, at the bottom of page 25, there are a review from the textbook questions to try. Guys, all the answers are on the remaining pages of your packet. Work shown and everything, okay? So you guys know where everything is. Nothing's up on Aspen, okay? Is there any formulas you would like me to go over right now? Or any of these topics we need to cover before I go over the couple review questions I've selected? I also just want to remind you, when I say the area formula for basic figures, let's say I'm talking about a rhombus, which is equal to 1/2 d1 d2. You may have to use Pythag. You may have to use 30, 60, 90. You may have to use 45, 45, 90. You may have to apply a property of a rhombus to get the diagonal legs. All right, so just don't think, oh, I know 1/2 d1 d2. That's good enough. No, it's not, unfortunately. All right, do you know the properties? Are you ready for 30, 60? Are you ready for 45, 45? Are you ready for Pythagorean theorem? Any formulas we want? Yep.
Well, for sectors,
yep.
Just mean like just finding them?
Find the area of a sector. Yes, and using the correct formula.
Wait, is this the sector is the shaded part, right?
The sector is the piece formed by the two radii. So if this is my center, draw in two radii. Probably, I'm just going to wing. Nope, didn't think so. The sector would be the shaded region right here.
And then the shaded regions are just like when you give us like two shapes and like a rectangle.
Yep, like if I have, something like this, and this is not, but it's the only thing that came to my head right now. Pop a circle in there. We'll pop a square in there. And then I start shading all this stuff around it. Shaded region stuff, yep. That's what I meant by shaded region. Anything else before we get going with the review problems, and then you can go on your own? Okay, let's go. Everyone be awake. Might get called on here. First one I want to do with you, number 5 from the review packet. Okay, so you got two regular pentagons that are similar to each other, and their sides are in a ratio of 4 to 7. All right, I got 4 to 7. Area of the smaller one's 128. What's the area of the bigger one? I need somebody to set up from yesterday a correct proportion now. The similarity ratio 4 to 7, area 128. What's the area of the bigger one now? All right, what proportion? A correct proportion can you set up from here based on yesterday's discussion? Here we go. 7. Got a proportion we could set up. All right, hold 1 second, Amy. Thank you for squaring the sides. You cannot just say 4 to 7. The side ratio and the area ratio are the same. Go ahead. Sorry, Amy, continue. There you go. Everyone all right? Got to square the sides. All right, got to square the sides. Some of us need a little pick-me-up, it looks like. Sorry, I interrupted nap time for one of you there. All right, looks like we need a little pick-me-up today. Here we go. And that'll end up being 100 and 392. And yes, tomorrow, half a point every time, no units. Okay, half a point every time, no units. 392 square inches. 6, here we go. Find the area of this shaded region. Well, usually I tell you guys, find the area of the whole thing and then subtract out the unshaded, but I have no idea what that whole thing is or had an area formula for it. Is there any way you can help me find the area of the whole thing, Will?
Make the little circle at the top of the circle.
Yep, this is a composite figure. So Will's saying, hey, let's draw a horizontal line over here. All right, so what is the area of the whole figure? It's going to be a semicircle. Anybody's area formula for a circle? 1/2 or pi r squared. Then I'm going to take half of it. Plus, what's the bottom figure there? Square, right? Length times width. And then we'll get to the unshaded in a second. But here we go. Fill in everything I need for me, please. Let's roll 5. Here we go. 1/2 pi. What's my radius? 5 squared plus length and width of the square. 10 and 10. Please don't round that answer because we're going to subtract it to the unshaded. Okay, we'll find that in a second. So now we'll take the area of the unshaded. And what figure is the unshaded? Here we go. 7. What figure is the unshaded? Okay, what's the area formula? Any triangle? 1/2. Base times height. Amy said it was a right triangle. What do I know about the base and height here? 12. It's the 2 legs in a right triangle, base and height, 10 and 10. And then I'll give you guys a second right now to find the area of the shaded region now. What do I do with those two to find the area of the shaded region? And let's just get in the habit, no units, so I'm going to write out my full calculator display here. Just give me the first couple numbers so I know we're on the right track, and I'll write the rest. Here we go, 20. 89.26. Okay, here we're good. 89.26990817 square meters. We okay finding that whole thing? All right. 10. Yes, Justin.
Calculator didn't bring out that last one.
That's fine.
Okay.
That's fine, yeah. Okay, find the area of the shade. What is the shaded region called here if that's the center? Got another name for the shaded region up here in a circle. Here we go, 20 again. Sector, all right, look back if you need to. What's the area formula for a sector I'll be using tomorrow? And the angle is the arc is in degrees. There's a little hint, arc is in degrees. So the sector formula I need for tomorrow, 13, 12. Okay, stop right there. What's the measure? 36 degrees over. Yep, times. And R value here, radius, 11 squared. There we go. Measure of the arc over 360 times pi r squared. Bless you. And there are no units here, so I wouldn't expect any units to be put on tomorrow. Don't, if you're going to write the word units squared, then don't do this because that's a totally different number than what you had. Okay, don't square the number. Okay, so just a quick review of the sector formula. I got 2 more, I think. Yep, 9. Another shaded region problem. Okay, so identify what is the whole figure up here. I think they tell you anyway. 15, what's the whole figure? It's a square, so let's find that area first. So the area of the square, length times width. And what do we know about the length and the width here? Here you go, 5, length and the width. Okay, 6 times 6, so the whole thing, 36 square inches. All right, a little bit different now. What's the unshaded part consist of? Unshaded part, what does that consist of? 10? Oh, all right, no problem. How about 20? The unshaded. Okay, sectors or anybody? 4 quarter circles, put them both all together. It's a full circle. Everyone agree? I got 4 quarter circles, put them together, that's a full circle, so I'm just going to use pi r squared. All right, put those 4 together, you get a full one. And be careful here, what would the radius be then of each circle? 2? It is 3. That's not the diameter. All right, from here to here, that's a radius length of 3. Yep, it's not the diameter. So that's 9 pi. Directions, express your answer. Terms of pi. What are we doing with these 2 right here to find the shaded region? We're going to subtract, add, multiply, divide. Subtract them, all right? So the shaded region is going to be 36 minus 9 pi. Can you combine those? No, you cannot. The 36 does not have a pi, so that's as far as I'm going to go, except I'm just going to add on square inches. No issues yet? And then you have one more here, which I wanted to go back to number 3 and do the kite problem on there, because we did not review the properties of a kite that you may need tomorrow. All right, well, first thing I need is, what is the formula for a kite? 20 again. Same as a rhombus, remember. Yep. How many diagonals are drawn in this diagram? 8. How many diagonals are drawn? And what's its length? Okay. Are diagonals congruent in a kite? No. And by the way, are they congruent in a rhombus? Are they congruent in a rhombus? No. So when you use 1/2 d1, d2, you should know what about the diagonals? Different lengths. Remember that tomorrow. No matter what formula, what figure you're doing, the diagonals should be different. All right, so I need help drawing it, finding the other diagonal. So let's draw it in. Anybody remember any properties of a kite? Even if you guess, you'll probably be right. Who you got, Will?
Longer diagonal bisects.
Correct. They do not bisect each other like a rhombus, but the longer one does bisect the shorter one. And one more property I'm going to need here, Justin. They are perpendicular. Just like a rhombus, they are perpendicular. And that allows me to use what to help find part of the diagonal? 17, Pythagorean Theorem. Okay. You want to set 1 up for me, Max? Yep, b squared. I'm hoping somebody listened to those properties we just went over of a kite. What's that length there? 4. What's that length going to be? 25? You move the 144 over? Oh, 25, yep, and then take the square root. That's what I was meaning. Take 5, yep. Hey. That doesn't mean that's 5. They don't bisect each other. It's not a rhombus. So what am I going to have to do one more time to find this length? Pythag again, all right? With the kite, the diagonals, the longer one bisects the shorter one, but not each other. So now I'm looking at 12 squared plus b squared, but now equal to 15 squared. And then what's the other length of that diagonal? 11 when you're ready? 9, yep. So what's getting plugged into? And that's off. I hate this example. But 14. And that ends up being 168. Go ahead, Maggie.
So with the half, do you do half the first diagonal, or is it half the product with the 2 diagonals? For the
Oh, no. Oh, it's just, it does, because it's multiplication, it doesn't matter what order you do them in.
so like no matter
I could have done 1/2 of 14, 1/2 of 24. It doesn't matter because it's all multiplication, so it doesn't matter the order you multiply them in. Okay. You guys, that's it for me. All right, you're on your own right now. You guys don't even have to get out your Chromebooks because the answer key's in the back. All right, so if you want to grab a textbook and start with those, that's fine. If you want to start with these, again, I can't warn you enough. This is not enough to get ready for tomorrow. Okay, look back at your notes. Make sure you know all the formulas. Going back to the first screen here, make sure you know your sector formula, your population density formula. All right. Maybe look back at the old Regents exam from last week. You guys can move around, work whoever you want. It's fine with me.